All right, let's jump right in. So when you hear the word database, what comes to mind? Probably something like a giant, dusty library, right? A static digital archive. But what if a database wasn't a library at all? What if it was actually a living, breathing organism? Well, that's the wild idea at the heart of YaFaD AI, a completely new take on middleware designed specifically for the AI era.
You see, in the world of AI, there's this silent killer that's holding everything back. We've built these incredible AI brains. They're like supercars, but we're trying to fuel them through a tiny, clogged fuel line. And that fuel line? That's our data infrastructure. The thing is, AI agents are hammering our systems with hundreds of times more queries than a human ever would. And our old-school databases, they just can't hang. So what do you get? Crippling latency, insane costs for storage you don't even really need, and this tangled mess of complexity that's absolutely strangling the ROI on these amazing AI projects.
So to fix this, just building a slightly faster digital library isn't going to cut it, not even close. What we need is a total paradigm shift. We have to completely change how we think about data. We need to stop hoarding it and start metabolizing it.
And this really shows you the difference. On one side, you've got the old way, the static archive. It's basically a digital hoarder, frozen, cluttered, treating every single piece of data as equally important, until the whole thing just collapses under its own weight. But on the other side, you have the living organism. This system doesn't just store data. It actively metabolizes it, constantly clearing out the digital noise to keep everything lean, super responsive, and, alive.
Okay, so how on earth does a living database actually work? Let's pop the hood and take a look at the anatomy of this thing.
So, at its very core, YaFaD AI is a hybrid. It's not just one technology, it's a combination of the absolute best of two worlds, creating a system that literally has both a brain and a super powerful nervous system. And here's how you can think about it. The brain is built with Rust. This is the Rust cortex, and it's all about uncompromising safety and mathematical precision. It handles the really complex calculations, like the decay algorithms we'll talk about in a bit. Then you have the muscle, and that's built with Go. This is like the system's spinal cord. It's all about raw I/O performance and network routing, orchestrating everything in parallel with blazing speed. It's this incredible synergy between the two that makes the whole thing so powerful.
But, a brain and muscle are pretty useless if you can't sense the world around you. So how does this thing actually perceive its environment? How does it know which data matters and which is just noise?
Well, it uses this really clever piece of tech called the zero-code SQL proxy. This is basically the system's nose and ears. It just sits right between your application and your database, completely transparently. Now, it lets about 99% of the traffic just fly right through, no problem. But it's always sniffing the data flow, listening for one specific thing: select queries. When it smells one, it shoots a quick pheromone signal up to the brain. And the absolute best part? You don't have to change a single line of your existing code. It just works.
And those signals, they're the key to the whole system's logic. It's called the pheromone principle. And the idea is actually super simple, but really profound. Think about ants, right? When they find a good food source, they leave a pheromone trail so other ants can find it. This system does the exact same thing, but for data. It marks useful data to ensure its survival. In this world, if you're used, you live.
So, here's how that scent of relevance actually plays out. Step 1, your application asks for a piece of data. Step 2, the SQL proxy sniffs that request and gives that specific record a pheromone boost. What that does is instantly crank its utility index. Think of it like a health bar, all the way back up to 100%. And step 3, that fresh burst of energy keeps it safe and sound in the ultra-fast, hot tier of storage, ready to go in an instant.
Okay, but what happens to the data that doesn't get used? Well, that's the other side of the coin: intelligent decay. This is basically the system's mathematics of forgetfulness. If a record doesn't get that pheromone boost, its health bar, that utility score, starts to slowly drain over time. It quite literally begins to lose its will to live.
So you've got this constant dance, right? Relevance boosts data up and decay lets it fade away. And this process allows the system to achieve something truly incredible: autonomous homeostasis. That's a fancy word, but it just means it can keep itself in perfect, self-regulating balance, all on its own. It's got these amazing internal systems, like a circulatory, respiratory, and even a digestive system.
Let's start with the circulatory system. Here, Data flows between different storage tiers. Think of it like going from super fast, expensive real estate in RAM down to slower, way cheaper storage on hard drives. It's like blood flowing through the body. And what's cool is this movement isn't based on some clunky manual rules. It's driven by a kind of systemic osmotic pressure that naturally pushes less important data down to the cheaper tiers.
And the one simple rule that governs this whole flow? It's a number. 1.618. You might know it as phi, or the golden ratio. It's this crazy mathematical constant that shows up everywhere. In nature, seashells, flower petals, even galaxies. And the system uses this exact same natural constant to maintain a perfect and really cost-effective balance between all its storage tiers. It's wild.
Okay, so what happens when things get crazy, like a sudden, massive burst of data? Simple. The system just breathes. It uses a special controller to inhale the huge data load, letting its hot tier swell up to handle it. Then, once the rush is over, it exhales, gently pushing the older data down the line until it hits that perfect golden ratio balance again. And once it's balanced, it goes back to a sleep state using almost zero CPU. It just rests.
And that brings us to the final system, digestion. What happens to data that's just been forgotten for too long? Its health bar drops so low that it's flagged as metabolic waste. It hits a point of no return, a black hole really, and it gets vaporized to shed that dead weight. Now, for things you have to keep for compliance, it can be archived instead. Think of it like being cast in amber for safekeeping.
All right, I know what you're thinking. This whole bio-inspired theory sounds amazing. It's fascinating stuff. But does it actually work in the real world? Let's look at the proof.
So to prove it, the system was put through an absolutely brutal stress test. They hit it with a pulse injection of 5 million records all at once, just to see if these organic, self-regulating ideas would actually hold up under extreme pressure.
And the results, honestly, they were remarkable. It processed all 5 million of those records without a single hiccup. And when the dust settled, the ratio between its storage tiers landed at, get this, 1.6182. A near-perfect state of equilibrium based on the golden ratio. And it did it all by itself, no human intervention needed.
But the evolution doesn't stop there with just one organism. The next step is a whole swarm. The system is designed to scale out using something called epidemic networking. Basically, individual nodes gossip with each other, sharing how busy they are. If one node starts to get overwhelmed, it can literally just cough a chunk of its workload over to a neighbor that's more relaxed. The load balances itself organically across the whole network, and you don't need a central master server telling everyone what to do. It's a true swarm intelligence.
So, let's bring it all home. What's the bottom line? What's the real payoff here? It comes down to 3 huge things. First, sub-millisecond latency. The system is so good at predicting what data you'll need, it has it ready before your AI even asks. Second, massive cost savings. You stop wasting money hoarding digital garbage. And third, and maybe this is the biggest one, true zero-touch autonomy. You get a self-healing, self-regulating infrastructure that actually breathes along with your workload.
Ultimately, this changes the entire conversation. We're moving away from just managing data and toward creating a true data-driven nervous system for an entire organization. And that leaves me with just one final question for you to think about. If your database could think and breathe and heal itself, what impossible problems could you finally solve?